Okay, from now on, I'm going to show how to create the OO programming in CodeSys. So I'm going to make a very simple Valve classes and then show you from the scratch. So now make a new project, empty project, and CodeSys OO project. Okay, there is nothing, but normally there is a two tabs. One is devices, the other one is a POUs, that is a programs. So I tend to create all the programs that kind of template. That the class is a template. Yeah, should be in the POUs, and all the application that requires instantionize from the POUs, creating in the devices. So class is a template, so I'm going to make it here. So this is our infra. Here is the infrastructure and POU function block. Give a name, C valve, like this. Yeah, you have created a C valve. Okay, so we're going to use a state machine. All the class and our component is based on the state machine. This time I'm going to create a state machine using the SFC language that is supporting from the IEC 61131-3. But we can use that state chart as a state machine. So yes, actions, state machine, SFC type, sequential function chart, but that can be a state machine. So give a name only in it. Okay, steps, transition, step. Oh, sorry, step. Okay, and transition. Bevel, first it is a start with the closed. As normal bevel we can imagine, opened. And when the state is finishes, go to closed. And we need to create make some transition conditions. So I'm going to use enumeration. So this infrastructure here, I'm going to create a folder again and data type. Here is and DUT enumerations and enum comment. First, old command don't know where the command is unless as long as we gave a command unknown, and from the unknown there is an opened, close. Okay, automatically increase from the 0. So okay, we need two variables for enumeration, so we can give comment and enum type. Yes. Okay, and if enumeration type is close, it goes to here, and font goes to here. This time I'm going to give one more things. Completed command is complete. Executed completely. Okay, and close and open. But once command is close command is executed, then state change it to the open. So let's see how it works. And this time we just need to execute the state machines. Okay, when our C valve is called. Okay, but this is it's not a good way. So normally I made one more method that call as a main, and I put all the things in a main. So as a caller, yeah, should execute to the main and in the cycle. So yeah, let's see that now I'm going to execute to the C valve, but we don't have any instance. So I'm gonna make a device. So here I need to add a device, add object, add a device here, and yeah, going to execute to the system on the our Windows runtime. So it's 64-bit, and I need to add a task configurations here, and the test compilation needed to register a one program. That program should be program type and give a name as a main. So we have to add a call that main in here. So in the main we can declare the my valve. That valve is a C valve type. Yes, okay, and needed to be execute the main we have declared. That's it. It's very simple, and then that will be execute. So I'm going to execute this valve before the execute. Yeah, that the runtime should be running. So I think runtime. Okay, our runtime is running. The command is currently unknown, and our state machine is closed. So in the watch window, I'm going to give a command. So that instance is this one, right? So the value is unknown. Prepare the value. I'm going to give a open step first. Oh, sorry, it's my fault. It should be open. Yes. So I'm yes. So when the state is closed and we can receive the open command, and closed command automatically ignored, and the state is opened, the only close command is effective. That is a benefit of the state machine and why we are using a state machine. So go to watch window again, give an open command, execute it. Yes, it is opens, and our open command is change it to open command, and yeah, close command here, yeah, back to close, and our command is still close. Yeah, so I want execute only one time, one set. Yeah, give a close and open command. Yeah, the state machine automatically, yeah, execute only, automatically ignore the command that not um, allowed in the state machine. So but that normally, so I want make action function. Here is a main action. So in the main action we can give a command complete command. So complete actions should be st, and we can choose that action method. Delete it. There is a subject and command completed actions, and here also we can set a same action method here. Okay, so yeah, once the command is completely executed, that means our state is transited. Yeah, it automatically go to the complete state. Okay. Yes, state machine is running right now. Okay, I'm going to give a comment. Here it is opened. Yes, once state is changed, the command is only one time executed. That's much clearer. Right? Yeah, command is changed, completed. Okay, so we can create a very simple our state machines using the class. This time I'm going to show you creating a visualizations for the C valve as a widget and multiple instances. Here's a visualization. Yeah, don't check active. Okay, the visualization is ready. Add one folder. The folder name is Visual widget. So I'm going to create one more visualization here. The visualization name is a C valve. That's how I'm created. And yeah, I'm going to add a component. First, I'd like to show some state. Okay, and here also, I'd like to show a state here. That state name, the first one is closed. And it's a little bit big. Second one is opened. Yeah, and okay again, and yeah, this time I'm going to open object with edit object with, and there is input and output. Give one instance name, give int and C valve. Then we can color variable using int, not a real instance. So here is a so actually I was going to add a state variable. So if the state variable in the state machine, that's actually SFC, the state is implicitly declared, so we can use the implicitly the name. So if you know the name, the state, for example, like the cell, then it show X is the state is activated, T is elapsed the time. Okay, for the state, so we can access. But if we want the state variable as explicitly, so you can declare the variable for like this. That type is SFC step type, and another thing, opened. Okay, then yeah, you can see the variables outside of the state and explicitly. So for example, now I'm going to put here, yeah, it is showing on in my intelligence, and yeah, two states are ready to see. And one thing I would like to give a method. One is close method and the other one is open method. So first I'm going to give the open method first, and the method can execute yeah, method creations, opens, and the other one close. Okay, the open is override the variable for command, and the command should be num command list open. That's it. And close is a close. Oops. Okay, there you are. Okay, in the widget, we can see opened get in open method here. So we can call a method here, and okay, and the other one should be close. Okay, here is a close. All right. Okay, and here visualization. This is the main visualization which is located by visualization manager. Okay, and we can call the visualizations on the C valve. So here is a current project tab. You can drag this one. Okay. Here is your C valve, and we should allocate my instance type as a C valve. Yeah, right. Okay, it is on the our visualization tab, and if you want to give some area or group box from here like this, and go to back. Save it, and it automatically appears with the group box. So nice, right? Okay, let's run the visualizations. Okay, the visualization is running. The file opened, goes opened, and closed, goes closed. So too simple, it's too simple, right? And close this, and this time I'm going to show multiple instances running with the visualizations. Here, the easiest way to creating a multiple instance is declare array 1 to 5 5 of C valve, and index. Okay, full IDX should be start 1 and 2 5. Do my valve is array and IDX. Index should be there. All right, and okay, and visualization also we can have 5 numbers of a C valve component, and they are working as independently. They don't interfere each other completely. So yeah, we need to reassign the variables. They should be 1 because this is the first one, and second one. We don't need to match each individual the buttons, and this is 3, and component object inside of the widgets. 5. Okay, let's run the visualization again and see how they work. They will work independently, surely. Okay, we can look. They are working. All the states in closed state, but if I open the first levels, only first levels are opened. Second, third, fourth, fifth. Yeah, So now I have created very quickly 5 number of C valves, the valves component. Okay, now I'm going to create some another version of a valve class that is uh, feedback type valve, which have a limit switch. Stand from here. I need to create one more class. Okay, here, see feedback valve like that. Okay, and that feedback valve is extend from C valve. Okay, so most of them are completely same. Okay, and I can create a state machine as well, because it going to have a different behavior of a state, and more state machine. Type should be SFC. Alright, okay, I'm going to create a different version of a state machine for feedback valve. Okay, and then yeah, later on I'm going it should have a different type. The first one is open limit boolean type. Open limit bool. All right, closed close limit type should be same bool. Right, okay, and it should have two more states. First one is opening transient state SFC. Second one is closing. Okay, so two state and two limit switch, and commands are same. Yeah, so those 1 2 3 4 and mains, and yeah, all the method actions and variables are, yeah, inheritance from the C valve. So that means the C feedback valve also have a same method. So we don't need to declare the close and open, yeah, method. So yeah, the thing we need to close the state machines for the, yeah, state. This time it will be more complex. Okay, and once it closed, and it is go to close the state. This is the actually simplified version of the state machine. There is a closing and B closed close limit. Okay. Okay, let's see how it works. Okay, I'm going to make an application for the feedback valve. Yeah, I main will execute each state machines automatically. There's a compile error. I need to find that. Duplicated definitions. The init should be different because this is a feedback, because there is init in the C. Okay, different init build state. All right. See the state machine is the first. Main my feedback valve comment. First is okay, it goes to opening, and I need to give a opening feedback switch. Okay, and give a closed comment. Okay. Okay, we can make a visualization for the feedback valve. Okay, ready to create the feedback valves. Okay, you can copy this one. All right. I think we can extend this one and we can change it, the input types in feedback valve. And we have extend the state machine as well, switches for the feedback. So this is too big. I'm going to reduce this. Okay. In and second one should be open limit switch. Okay, give a rectangle, give some order, and real visualization. We're going to place the feedback valves here, and then we can give a variable instance. My feedback valve automatically showing on there. Okay, can we run? Is in closed state. If I push the close open button, it goes to opening, and if I make the open switches, okay, change it to the opened, and if I close, and it goes to closing state, and make the limit switch is on, and go to close the switches. Okay, go again. Okay, go again. Yes. So now we have completed created feedback type valve. So this time we also can create the multiple number of the instances as well. It is a very quickly possible, just copying the object and declare the array number of the feedback valves together. See feedback valve, put in the for loop, and visualization, copy. I located this only three number of the widgets, and yeah, the references should be array 1, 2, 3. Okay, let's run it again. We have a three number of feedback type valves. Will it run? Okay, you see, here is a three different type of feedback valves. Open, opens, close, closing. This one also opens, closing, closing. Yeah, now we have created very easily all the type of instances. So next time I'm going to create one more different type of valves. Now I'm going to create another variation of the valves that is a delayed time valve. yeah, that transition is go to the transition after a certain time. So give a name, see the delayed valve that also can extend from the C valve. And it also have a state machine, but different things. So gonna remove everything. Start with closed and give a transition again. Step transitions. So basically, it is a very simple with C valves, but C valve it transited after immediately. But this time, I'm going to give a certain time. So this time I'm going to use the how to use the this one, the election time. For example, if I want 3 seconds, you can use like this. But this is actually not we want. We need to add variable as tim open delay time preset. Initial is 3 seconds. Okay. And closed delay time. So we can adjust the time. So use if we can use if we use the state machines elapse the time, we don't need to declare more timers. Actually, in the traditional way, we had to declare the timer, on delay timer or off delay timer, and measures after the timer has elapsed. But this time, we don't need to spend the timer instance. And we need a command should open, so we can make like this, and the other one, and we need to jump to the close. And okay, yes, it's done. Okay, and we also give a new widget for the visualization and can give delay time. For the delay variable, I would like to give a preset time and elapsed time currently. I think okay, here time there, and then the variable should be and the closed t. it should be C delayed time. Delayed build. There is a text build. And close delay. Different shape. Okay, the variable should match with. This is open delay. And this is a close delay. All right. I think there is just some placeholder for only for remain second. I need to find out this time. We need only second. Percentage T. This one. So can give second. But if we want some give some minutes, okay, we can use the placeholder using minute. Online change again. Okay, close the state is after 3 seconds open the state is running, and after 3 seconds again come and close the state. We can't see opening and closing state, so we're going to add opening and closing state together like feedback valve. All right, running visualization again. Okay, open 2 3 go opened, close 1 2 3. Okay, if I okay, so now we have created another variant of the valves. So Torah, now we have 3 types of valve. One for C valve is very simple valve, and which the another one is having limit switches, and the another one is having some delay times. Okay, so now, yeah, I think these examples give some helps understanding about the OO programming.